Here we'll be looking at L'Hopital's rule for indeterminate exponential forms. So what are these exponential indeterminate forms? Well, these are limits that are of the form 1 to the power of infinity, 0 to the power of 0, or infinity to the power of 0. So let's look at an example. Say we're trying to find the limit as x goes to infinity of x to the 1 over x. Well, if we just find the limit as x goes to infinity without using L'Hopital's rule, we'll see that this limit is of the form infinity to the 0, which is one of our exponential indeterminate forms, meaning we can use L'Hopital's rule. So let's first define y is equal to x to the 1 over x. And if we take logs, we'll see that ln y is equal to 1 over x times ln of x, which is equal to ln of x of x. Now our limit becomes limit as x goes to infinity of x to the 1 over x, which will be our limit as x goes to infinity of y, which is equal to the limit as x goes to infinity of e to the ln of y using log laws, which is equal to the limit as x goes to infinity of e to the ln of x over x. Now, using log laws, this will be equal to e to the limit as x goes to infinity of ln of x over x. And we can actually use L'Hopital's rule on this expression over here. So now, if we use L'Hopital's rule, we find that this is equal to e to the limit as x goes to infinity of 1 over x differentiating ln x over 1 differentiating x. And this, if we take the limit of 1 over x as x goes to infinity, we find that this limit will be equal to e to the 0, which is equal to 1. And that's how we use L'Hopital's rule for exponential indeterminate forms. Just to recap, we have to define our function of our limit to be another function y. Then we find the limit of this function y, and then we can exponentiate and use L'Hopital's rule to find our final value for our limit, which in this case is 1. And that's how we use L'Hopital's rule for exponential indeterminate forms.